Hi everyone, I'm going to begin with free response question number 6 from the 2022 AP exam. We are given the function f that is defined by the power series f of x, which is seen right here. For part A, we are using the ratio test to determine the interval of convergence. I begin by setting the limit as n approaches infinity inside absolute value bars, and for every nth term, I add 1. Then, I will multiply by the reciprocal of the original summation. I am able to cancel out like terms, the negative 1 to the n and the negative 1 to the n up here, as well as the x to the 2n with these two as right here. I am able to reduce as x to the third over x reduces to x squared, and 2n plus 1 over 2n plus 3 are combined right here. Using the n behavior model, you can see that 2n over 2n will reduce to 1, meaning that x squared times 1 is x squared, so x squared is all that's left inside the absolute value, and you set this less than 1 because of the ratio test. And the series converges when x is between negative 1 and positive 1. Now you have to test your endpoints to see if they are included. So first I'm going to test x equals negative 1 by plugging negative 1 into the original series. So you get negative 1 plus 1/3 minus 1/5 plus 1/7, and so on and so forth. By using the alternating series test, you can see that this is positive, decreasing, and the limit equals 0, and therefore the series converges by AST. So that means that negative 1 is included in the interval. Now I'm going to test x equals positive 1, and I'm going to plug in positive 1 into f of x up here. So you have 1 minus 1/3 plus 1/5 minus 1/7, and so on and so forth. Using alternating series test, you can see it's positive, decreasing, and the limit equals 0. Therefore, the series converges. This means that positive 1 is also included in the interval. Therefore, the interval of convergence is negative 1 to positive 1. Part A is worth 4 points, and in order to get the first point, you would have to set up the ratio right here, and you would get the second point for identifying the interior of the interval of convergence, which would be right here, and then you would get another point for considering both endpoints, which is x equals negative 1 and x equals positive 1. And then you would get the last point for analysis in determining the interval of convergence. For part B, we need to show that the absolute value of f of 1/2 minus 1/2 is less than 1/10. So I began with realizing that a sub 1 is equal to x equals 1/2 when n equals 1. So I plugged in 1/2 for x right here, and then I plugged in 1 for the n value, and I was able to solve and reduce until I got 1/24. And the series for f of 1/2 is an alternating series whose terms decrease in absolute value to 0. The first term of the series for f of 1/2 is 1/2. The alternating series error bound shows that f of 1/2 differs from 1/2 by at most the absolute value of the second term of the series. So this part B is worth 2 points. You will get 1 point for using x equals 1/2 in the second term, and another point for the justification right here. Continuing on, for part C, we need to write the first 4 non-zero terms and the general term for an infinite series that represents the derivative of f of x. So I began by copying down the original function right here, the original series, and then I started taking the derivative, meaning that for a derivative, you subtract 1 from the exponent, and then you move the original down. So x to the third, I brought the 3 down, which cancels with the denominator, meaning that there is no longer a coefficient, and that when I subtracted 1, so 3 minus 1 is 2, and that becomes this term. And then I repeated that for all of these in order to get the derivative to be 1 minus x squared plus x to the 4th minus x to the 6th, and then the general term to be negative 1 to the n, x to the 2n. Part C was worth 2 points, and you would get 1 point for the first 4 terms and another point for the general term. Finally, for Part D, we are using the result from Part C to find the value of the derivative when you plug in 1/6. I plugged in 1/6 into this derivative up here, and I noticed that a sub 1 is equal to 1, and r is equal to negative 1/6 squared, which is equal to negative 1/36. So the sum is equal to a sub 1 over r1 minus r, so that means that a sub 1 is 1, so we have 1 over 1 minus a negative 1 over 36, which means that is 1 plus 1 over 36, which also is 1 over 37 over 36, and if you multiply by the reciprocal, then you would get 36/37, and Part D was worth 1 point just for the answer. Now I am doing free response question number 3 from the 2018 AP exam. We are given the graph of the continuous function g, which is equal to the derivative of function f. For Part A, we are said that if f of 1 equals 3, what is the value of f of negative 5? So I begin saying that f of negative 5 equals f of 1 plus the integral from 1 to negative 5 of g of x, and you can switch this by creating a negative here and switching these bounds, and then I plug in the 3 for f of 1 and continue to rewrite the negative 5 to 1 g of x dx, and then I plug in the bounds, and by doing this, since we are given the graph, we can find the area. So we have 3 minus a negative 3 times 3, which is this area right here, plus 1/2 1 times negative 3, which is the area of this triangle right here, and then plus 1/2 1 times 2, which is the area of this triangle right here. And in order to simplify, you eventually get 25 over 2. And Part A of question number 3 is worth 2 points. You can get 1 point for the integral and 1 point for the answer. Part B asks us to evaluate the integral from 1 to 6 of g of x dx. So I begin by splitting up the integral with its bounds from 1 to 3 and 3 to 6, and I did this because it was given that g of x equals 2 minus 4 squared for x between 3 and 6, which is from here to here, and then you can find the area from 1 to 3 right here. So I did that, so that's 2 times 2 right here, and then I continued by bringing down the integral from up here and plugging in the g of x function. So you have 4 plus, and then you can plug in your bounds from here, so you end up getting 4 plus 2/3 to the 2 to the 3rd power minus 2/3 to the negative 1 to the 3rd power. You can continue simplifying and combining like terms by making everything go over 3, eventually getting 30 over 3, which reduces to 10. Part B is worth 3 points. You can get 1 point for splitting the integral at x equals 3, which would be right here, this step. You can get 1 point for the antiderivative of 2 parentheses x minus 4 squared, which would be right here. And then lastly, you would get 1 point for the answer. You can also confirm this by looking at an IDM chart where it is where the derivative is positive, the original function is increasing, and if the derivative is increasing, then the original is concave up. Part C is worth 2 points. You get 1 point for the correct intervals and 1 point for a reason. Part D asks us to find the coordinate of each point of inflection of the graph of f and give a reason for our answer. So on the graph of f, you can see that an inflection point is where the derivative is at a max or a minimum, and you can see that the graph of f has a point of inflection at x equals 4 because the derivative changes from decreasing to increasing right here. And part D is worth 2 points, and you get 1 point for the answer and 1 point for a reason. For multiple choice question number 10, we are using the second derivative of a function to find inflection points. On the IDM chart, when there is an inflection point on graph f, that means that there is an endpoint, 0 or undefined, on the second derivative. To begin, I set each of these three components equal to 0, and I got x equals 0, x equals 3, and x equals 10. These three are all possible inflection points. To confirm, we went to the first derivative where there's an inflection point, which is a max or a min. And in order to test it out, if it's max or min, that there must be a sign change in between. So I chose different test points, for example, -1, which is less than 0, and I plugged the -1 into each of these three for x's. We get a negative times a negative times a positive, which makes a positive. For the second test point, I chose 2, which makes a positive times a negative times positive, which is a negative. The switch from positive to negative makes 0 have a maximum, which means that 0 is a point of inflection. I repeated these steps using the test points 5 and 15, and there was another minimum here at 3, where there's a sign change from negative to positive, but then for 10, there was no sign change, and it went from positive to positive, meaning that there is not a point of inflection. There's only a max and a min here at 0 and 3, which means that B is the only answer. For multiple choice question number 11, we are asked to integrate from 0 to pi of e to the x minus 1 over e to the x minus x dx. So I began by letting u equal e to the x minus x, and then I took the derivative of this, so du equals e to the x minus 1 dx. I plugged in my new bounds for this, and you get 1 to e to the pi minus pi, 1 over u du. 1 over u can also be written as 1 to the negative first power, and then since you're integrating, you add 1, but when you add 1, you get to 0, which means that this will be an ln. So you have the ln of u from 1 to e to the pi minus pi, and you plug in your bounds, getting ln e to the pi minus pi minus ln1, and ln1 is equal to 0, meaning that you only have ln e to the pi minus pi, which matches with letter choice D. For multiple choice question number 20, I was able to eliminate answers based on the properties of definite integrals. For letter A, this is seen as a reversal of limits, meaning that the bounds have been switched from 1 to 4 to 4 to 1, and this is able to be done by moving a negative out in front of the integral. Letter B shows the multiplication of a constant. This is another property of a definite integral. This is able to be done as well. Letter D shows the addition of two functions, meaning that f of x is added to g of x, and this is another property able to be done by definite integrals. And by process of elimination, there is only one answer left, meaning that C cannot be determined from the information given. For multiple choice question number 21, we are finding the integral of convergence for a series. I used the ratio test, where the limit as n approaches infinity is placed inside absolute value bars. I rewrote the original summation, but for every n, you add 1. Then you multiply by the reciprocal of the original summation. We were able to cancel like terms, with the x plus 4 to the n canceling with this one, the n canceling with this one, and the 5 to the n canceling with this one here. This leaves an x plus 4 to the first power, and the 5 to the first power up top, and the 1 and 5 to the second down bottom. This results in a 5x plus 20 over 25. You can reduce this to get x plus 4 over 5 in absolute value, which is set less than 1, which is where the ratio test converges. To simplify, you multiplied both sides by 5 and then subtract 4. This gives you the interval of convergence from -9 to 1. Usually you would need to test the bounds for convergence to see if the endpoints are included, but since it is a multiple choice question, there is only one possible answer, which is A, -9 to 1. And lastly, we have multiple choice number 30, where a function f has a Maclaurin series given by this right here, and it converges for all f of x for all real numbers x. If g is the function defined by g of x, which equals e to the f of x, what is the coefficient of x squared in the Maclaurin series for g? So first I set g of x equal to e to the f of x, and I took the derivative, and this is a u-v problem, so you have the u and then the v, which means that when you take the second derivative, you have u ticky v plus uv ticky, and now I took each of these, so I found the original function of f, the derivative of f, and the second derivative of f, and I solved each of these I started with the original, and then I took the derivative of each, and then I plugged in 0 because x equals 0, because it is a Maclaurin series, and 0 is always the center. And I got these values, so then I plugged each of these values into its corresponding, whether it was the original function, or the derivative, or the second derivative, to get this right here. And this simplified down to 9e squared plus 2e squared, which is 11e squared. And this means that this is the coefficient that goes over the x squared in the series. So we have 11 squared, parentheses x minus 0, which was the center squared, over 2 factorial, and 2 factorial reduces it down to 2 times 1, which is 2. So we have 11e squared over 2, which is letter choice D.